I will record. So back in algebra a couple years ago, you probably learned about linear inequalities and, things like x plus 7 is greater than 2, or, stuff like that, and solving those and finding the solution set. So today what we're going to do is quadratic inequalities, and then on Monday we'll talk about higher degree inequalities. So we want to be able to solve the quadratic inequalities and get answers that are in interval notation. And then we also want to be able to graph quadratic inequalities and get answers that are on a number line. So here we go. That out of the way. Okay. So write it in orange. 2.6 quadratic inequalities. Quadratic inequalities. Okay. So our first one, we're just going to kind of go through these with an example to start with. So a quadratic inequality is going to look something like this. You'll have x squared minus 3x minus 15 is greater than 3. So we'll see something like that. And the first thing that you want to do is make it less than or greater than 0. So we want to get 0 on this side over here. So I'm going to subtract the 3 over. So we get x squared minus 3x minus 18 is greater than 0. Okay. The next thing I would do is factor this thing. Or you could find the zeros in any other way that you like finding zeros, including using the quadratic formula or plugging it into Desmos and clicking on the zeros, or whatever other graphing calculator you like to use. I'm going to factor this since that's pretty quick and efficient right here. This one, things that multiply to negative 18 and add to negative 3, that would just be negative 6 and 3. Okay, so once you've factored it, find the zeros. If you graphed it, you already have the zeros. In this case, the zeros, x minus 6 equals 0, x plus 3 equals 0 gives us x equals 6 and negative 3. Okay, so far so good. We factored it, we found the zeros. We haven't really dealt with the fact that it's an inequality yet. That's where this comes in, this next step here. So we need to next make a Sine chart. With the zeros. So here's what a Sine chart looks like. It's kind of like a number line. If you haven't seen one before, or a Sine chart before, not a number line, I'm sure you've seen a number line. A Sine chart with the zeros is going to look like this. We've got one of our zeros, the smallest 0 is over on the left, and then you write down the rest of your zeros along here in order of increasing values. And so what I'm going to do is I'm going to check a value in each of these ranges. So I'm going to check something that's less than negative 3. I'm going to check something that's between negative 3 and 6. And I'm going to check something that's greater than 6 to see what the value of the function would be at that spot, which will tell me what the value of the function is overall in this range. So So something that's less than -3, usually you want to just like pick numbers that will work nicely. Like if you can pick 1 or 0, if those things are in your range, then do that. If you can't pick like 1 or 0, that's okay. In this case, something that's less than -3, I'm just going to pick x equals -4. So we're going to figure out what is f of -4. In this range, the nice thing is that x equals 0 resides there, so we'll figure out what is f of 0. And then greater than 6, you can pick any number greater than 6. I'm going to pick 10. So we'll find f of 10. Okay, and then the thing that I'm plugging it into is this, the one that's greater than 0, because that's what I factored and that's what I've been working with. So we're having f of x equals x squared minus 3x minus 18. So it's whatever you had that is greater than or less than 0. That's what you're plugging it into. So plugging in -4, -4 squared is 16, minus 3 times -4, so that would be plus 12, and then minus 18 gives us 10. If I plug in -4, I get 10. And that's a positive number, so I'm going to put a plus here, which tells me that this whole range of values is from -3 to -infinity there, is positive. X equals 0. If I plug in 0 here, we get -18. So that's negative. If I plug in 10, let's see, 10 squared, so 100 minus 30 minus 18 gives me 52, which is positive. Okay. So we made a sign chart with our zeros. We figured out where the function is positive, negative, and positive again. The last step is to put your answer in terms of intervals. So solution, intervals. Okay, so this is where we have to go back to the whole greater than or less than 0 thing. So we know that we're graphing x squared minus 3x minus 18 is greater than 0. So we want to know the intervals where the function is greater than 0. Well, that would be the places where it's positive, right? So that means that from -infinity to -3, our function is greater than 0. And from 6 to infinity, it's also greater than 0. So our intervals would be -infinity to -3, unioned with 6 to infinity. So in other words, we're looking, since we want it to be greater than 0, we're looking for the intervals of positive for this quadratic. So this would be our answer if we were looking to find the solution in intervals. If we were looking to plot it on a number line, then it would be an open dot at 6 and an arrow pointing to the right on your number line, an open dot at -3, and an arrow pointing to the left on your number line. And it's an open dot because we have it's greater than strictly, it's not greater than or equal to, because -3 and 6 are the places where the function is 0. Okay. So most of the work that goes through here is assuming that we don't really have graphing capabilities, but we do. So let's take a look at what this would look like if we were to graph it and kind of figure out what's going on. So keep in mind we started with x squared minus 3x minus 15 is greater than 3. I'm going to move it to what we had in the first step where we make it greater than or less than 0. So we had x squared minus 3x minus 18. So if we look at this, notice that this is basically our sine chart here. The function is greater than 0 when when the x value is less than -3. And then also when it's greater than 6. In here, from -3 to 6 is all where it's less than 0. So if I want to know where it's greater than 0, I just look at the places where it's positive, where the function is positive. You can also see it graphed in this fashion. If you just plug this into the graphing calculator, you can see that it shows you your intervals where it's positive, from 6 to infinity, and from -3 or negative infinity to -3. And that the only area where it's not is in here. And it even shows you the dashed line. You have a dashed line here and a dashed line here. And the nice thing is that the graphing calculator, Desmos, will do this if you have something that factors nicely and has good values, or at least somewhat exact values here. The problem is when it's an irrational number, Desmos isn't going to, when you click on it, tell you that this is 2√2 or something like that. And so it is good to know this method of doing it with factoring and things like that, so that, or with the quadratic formula, if you have something that doesn't factor nicely. So that in those cases where you can't click on the zeros because they aren't rational numbers or they just don't show up nicely, you still have something to fall back on here, and you still kind of know how this works. Okay, so that's one example of how we could solve a quadratic inequality. Are there any questions with that one? Any numbers we're not sure where they came from? Steps in particular that we're not 100% sure how they work? Anything we want to ask at the moment? Okay. Let's see, if we don't have any questions at the moment, let's do another one. Let's go with x minus 4 squared is greater than or equal to 4. All right, well, step 1 was to make it greater than or less than 0. So first I'm going to distribute this out. We get x squared minus 8x plus 16. And then subtract 4 from both sides to get the 0 over here. Okay. At this point, you could stick it into Desmos and see what you get. Or to do it by hand, we can go through it this way. We're looking to factor this thing, so we're looking for things that multiply to 12 and add to -8. -6 and -2 sound pretty good to me. So we get x minus 6 times x minus 2. So then our zeros are x equals 6 and x equals 2. So we make our sine chart. So in here, I'm going to check x equals 0 because 0 is less than 2. Between 2 and 6, I'll check x equals 3. Between 6 and infinity, we'll check x equals 10. So we want to find f of 0, f of 3, and f of 10. And we're using x squared minus 8x plus 12, since that's what we found the zeros to be from. So f of 0 is going to be 12. F of 3 squared is 9, minus 24 plus 12 gives us negative 3. And then 10 squared is 100, minus 80 plus 12 gives us 32. So we have another situation where it's positive, negative, positive. And since we wanted greater than or equal to 0, that tells me that my solution intervals are going to be negative infinity to 2 inclusive, and including 6 to infinity. So if I was expressing my answer in interval notation, this is what I would put. If I was expressing my answer on a number line, we would have a solid dot at 2 and an arrow going left, and a solid dot at 6 with an arrow going right. Okay, so that's another example of a very similar question to that. You could also graph this on Desmos, and it would show you the same kind of picture that we saw before, except it would be a solid line at 2 and a solid line at 6, with the right of 6 shaded and the left of 2 shaded. And that's a good way to check your answer too. If you're practicing doing these by hand, a good way to check your answer is to use the graphing calculator. Okay. Any questions before we move on to a different, some different cases and scenarios you might see? Okay. How come the intervals include 2 and 6? Good question. That is all down to this. We have greater than or equal to. So they're included if we have a greater than or equal to or a less than or equal to symbol. But since the place where 2 and 6 are equal to 0 here, like since those are the zeros of the function, that's, since they're equal to 0, that's why they're covered in that or equal to bit. It's kind of like, yeah, when you were doing it with linear ones, if you had a greater than or equal to, it was a closed dot. If it's a strictly greater than, it's an open dot. Same idea as algebra. Good question. Yeah, so interval notation, the bracket is the same as like a closed dot on here. Any other questions or anything before we look at some other cases? Okay, so let's look at some other cases. We're going to call this example 3A. So we're going to take x squared plus 5x plus 8 is less than 0. Well, this one's kind of nice because they've already got it with a 0 on one side for us. So that cuts out a step. But that's about where it stops being so nice. Because you look at it and go, well, if I try to factor this thing, there's nothing that multiplies to 8 and adds to 5. Those things don't exist. So we want to grab that quadratic formula, and we also might want to graph this. We're going to look at both of those things. So the quadratic formula, remembering negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 5 plus or minus the square root of 5 squared, which is 25, minus 4ac, so that would be 4 times 8, which is 32. And we can pretty much stop right there, but 2a would also be 2. We can stop right there because notice that the number under the square root is going to be negative, which is going to tell me that I have no real solutions. No real number solutions. But I can't just stop here for this and say that there are no real solutions yet, or that there's no solution to this, without taking a look at the graph first, or without checking some values, one of the two. So we're going to take a look at the graph of this. So we had x squared, oops, not x to the fifth, x squared plus 5x plus 8. And notice that all of the values for this function are positive. So since we're looking for the case where we're looking for this to be less than 0, but the function is always greater than 0, then yes, there is no solution to this particular question, or to this particular inequality. This one has no solution. But example 3b, we're going to look at the same thing, but slightly different. Example 3b, we're going to go x squared plus 5x plus 8 is greater than or equal to 0. So we have the same issue. We can't factor this thing. So it's the same problem. There's no real zeros, but we've got a different symbol here, greater than or equal to 0 instead of less than 0. So my question for you is, where is this function greater than or equal to 0? What do you think my solution interval is going to be? So where is this function greater than 0? Everywhere, right? This function is greater than 0 for any value of x. So that means my solution here, so this one, the function was always greater than 0. That still holds true. So since this one was always greater than 0, and we want to know when it's less than 0, that's why we had no solution on 3a. But since we want to know where it's greater than or equal to 0, well, it's always greater than or equal to 0. In fact, it's always strictly greater than 0. So since this is always greater than 0, then our solution is negative infinity to positive infinity. So when you end up with no real zeros, you do want to check and see what the graph looks like, or plug in a value here, because whatever you plug in, the sign of that is going to be the sign of everything on your graph, because it never crosses the x-axis. It has no zeros. So the sign of everything on your function is going to be the same as, like, if I plug in 0 here, we get 8. So that means everything in that function is going to be positive. So then you have to think about that and think about what you're being asked. And then decide if you either have no real solutions or all real numbers as your solution. Okay, so that's a little bit of a different case, but interesting things to think about. All right, I'm gonna have you guys try one. We're gonna do x squared plus 5x plus 6 is less than 20. So take a couple minutes, try solving this one. I want to see the solution as a graph and as interval notation. So take a couple minutes and work on this. When you think you've got it, type done in the chat. You got 2 and -7 for your zeros. You're on the right track. If you got something else for your zeros, go back and check how you got those. Okay, so as we start going through this, and as people start finishing up, from someone who finished it and thinks that they've got it, what was your answer interval? What'd you pick? Anyone think they've got the interval? Nice. I agree with you. Let's find out why. So When I plug in -10 here, or you could plug in anything that's less than 7, I got 136. When I plug in 0, we got -14. And we plug in 3, and you get 10. So we have positive, negative, positive. But this time we're looking for the space where it is less than 0. So we want the ones where it's negative. So this is the chunk that we want. So our answer would be not inclusive because it's strictly less than -7 to 2 for our interval answer. And then our number line answer would look something like an open dot on 7, an open dot on 2, and a line connecting them. Okay, so that's what we've got there. Any questions from any of these? Any numbers we're not sure where they came from? Things we're not sure how they work? Keep in mind for a lot of these, you can graph them and see what they look like just to double check yourself. Okay. If you do have any questions, feel free to unmute yourself and say so, or type in the chat. In the meantime, I'm going to post the assignment, and for those of you who want to get started on it, you can get started on it. For those of you who want more examples, you can stick around and we can do more examples. Okay, so today's assignment is brought to you by IXL. There are 2 sections. One is involving finding your solutions by and graphing them. The other one is solving them and putting them in interval notation. So we have graphing quadratic inequality solutions, and nice, this one already has it all factored for you and everything. And then we also have solving quadratic inequalities and putting them in interval notation. Okay, I'll post an exit ticket in a little bit. Otherwise, you're free to head on out.